Hey everybody, welcome back to the 11.4 notes. In this video we're going to still be calculating areas of regular polygons. However, we're going to be using trigonometry or special right triangles in order to figure out a missing piece that will then enable us to find the area of a regular polygon. So at the top of the notes here, let's go over what it means to be a regular polygon. A regular polygon is a polygon that is equiangular, meaning all angles are equal in measure, and equilateral, meaning all sides have the same length. And so at the top of these notes, I put our 45, 45, 90 and our 30, 60, 90 special right triangles, and then a recap of your sine, cosine, and tangent functions. Remember SOHCAHTOA? And then at the bottom here, I have our central angle formula, which is 360 over n being the number of sides in a polygon. So for this first example, I'm going to be finding the area of a regular pentagon, a pentagon being a five-sided polygon. And so we're given that PR is 10. PR is not the apothem. Remember, the apothem would be PS. So 10 is actually a radius, because if you were to circumscribe a circle, look how good that circle looks. But if you were to circumscribe a circle around it, PR would actually be a radius. So anyway, I'm just trying to tell you that this is not the apothem. And so if we're going to figure out our area, we need to figure out our apothem, and then we need to figure out our side length. So the first thing we'll want to do is calculate our central angle. And so since this is a pentagon, our central angle is just going to be 360 divided by 5, which is going to be 72 degrees. That's telling me that this angle P is 72 degrees. So it's including both of the little triangles, if you will. So it's angle RPQ. Now, to figure out PS, your apothem, what you should do is isolate one of those two little triangles, because they are both right triangles. And so we know that 10 is our hypotenuse, and we're looking for PS, so I could put an X right there. And so, that's basically the height of this right triangle. And we know that 72 degrees is the big angle P. So if I use one of these little right triangles, I'm cutting that in half. So half of 72 is 36 degrees. And so with this information, I can actually use the cosine function in order to figure out what x is. The reason why I can use cosine is because x is the adjacent side to the 36 degree angle, and then 10 is opposite of the right angle, so that makes it the hypotenuse. So I'm going to set this up by saying cosine of 36 degrees equals x over 10, adjacent over hypotenuse. So to solve for x, if you were to throw cosine of 36 over 1, you'd cross multiply these two and then divide by 1. In other words, x is going to equal 10 times cosine of 36. And you could type this into your calculator and get the number, but then you'd have to round that number. And x is just the apothem. We still got to figure out the perimeter. And so what I'm trying to get at is, if you don't have to round, then don't. I can use this for the length of my apothem instead of a rounded answer and get a more accurate answer at the end. So I'm going to keep this as 10 cosine of 36 the whole way through, okay? So now that we have figured out our apothem, we need to figure out our side length. Basically, we need to figure out RQ. Well, it's easiest right now to figure out what RS is. I can call RS Y, since I called the other side X. And if I figure out what Y is, I'll be able to figure out what RQ is, because I can just call that 2Y. Because remember, we basically just cut that in half. Line PS cut in half RQ. So if you figure out Y, just double it. You can figure out your side length and then multiply it by the number of sides you have, and then you'll figure out your perimeter. So looking back at the right triangle I drew earlier, Y is actually the opposite side of 36, which means I can use sine. So I'm going to set this up as sine of 36 equals opposite over hypotenuse, in other words, Y over 10. And just like the other one, you can throw this over 1, and when you cross multiply, you're going to multiply 10 times sine of 36 and then divide that by 1. So y is just going to equal 10 times sine of 36. And so since we need to figure out what 2y is, because we need two of those to figure out our side length, I can say 2y is, and just multiply that 10 times 2. 10 times 2 is 20, so I can say 20 sine of 36. And just like the same rationale I had before about not typing this into the calculator, because then I'd have to round that number, I'm going to use that same logic to not round this number right here. And so anytime I need to use my side length, I'm just going to use 20 sine of 36. So if one of my sides is 20 sine of 36, then all 5 of my sides are 20 sine of 36. So to figure out my perimeter, I just need to do this times 5, which is going to be 100 times sine of 36, because 20 times 5 is 100. And so knowing my perimeter is 100 sine of 36, and knowing that my apothem is 10 cosine of 36, I can now calculate my area. So if my area is 1/2 a times p, apothem times perimeter, then my area is going to be 1/2 times 10 cosine of 36, and then multiply that times my perimeter, which was 100 times sine of 36. And so typing that into my calculator gives me an area that is approximately 237.764 square inches. So for my next example, I'm going to do the area of a square. And so the area of a square formula is just length times width. And 7 is not a length or a width, it is a diagonal. And so what you'll want to do is make a right triangle from that diagonal. And so it might help to actually just draw it on the side. And so you have 7 here, and then you can put a little x there. And just like the last one, x is going to be half of that side, so you could put another x there if you wanted. And the point I'm trying to make again is that that whole side will be 2x. So whatever we figure out for this bottom side length is going to be half of the side length of our square. Next, let's figure out what that central angle should be. The central angle is 360 divided by the number of sides, which is 4, so that's 90 degrees. That's saying if you had the triangle going like this would be a right angle right here. So that means if you were to cut that triangle in half, you would have a 45-degree angle there, you'd have a right angle there, and so you'd have another 45-degree angle there. So this is where it helps to know your special right triangles, because you can save yourself some time doing some trig. But even if you didn't, the trig will still give you the same exact answer. Looking at this, remember the 45, 45, 90 triangle, say, goes x, x, x square root 2. And so if 7 is your x square root 2 side, then what you want to do is cut 7 in half, that's 3.5. And so instead of saying 3.5 times 2, you're going to say it's 3.5 times the square root of 2 times the square root of 2. And so that helps you figure out that this is your x, and then this is that extra square root of 2 because you're on the square root of 2, the x square root 2 side. And so, long story short, x is going to equal 3.5 square root 2. And just to kind of quickly go over it, if you didn't figure that out or you didn't catch that this is a special right triangle, well then 7 is your hypotenuse, right? And then you just need to use one of the 45-degree angles. So I'll just use this one and say x is opposite of that 45-degree angle. So what uses opposite in hypotenuse? That's sine. So you can say sine of 45 equals opposite over hypotenuse, x over 7. So then you take that 7, multiply it to the other side, and so you're going to have x equal to 7 sine of 45. And if you were to type in 7 sine of 45, it would be the same thing as what 3.5 square root 2 equals. They equal the same thing. So however you want to go about this to use for your side length is fine, because you'll have the same number. So if I want to figure out what 2x equals, I'm going to say that 2x will equal 14 sine of 45. Or I can say just multiply 3.5 times 2, that's 7. So 7 square root 2 is what my 2x side equals. So I'm going to go back to my square here, and since 7 square root 2 is less to write down, I'm just going to write down a 7 square root 2. And so area is length times width. The square has the same length and the same width. So really all I need to do is 7 square root 2 times 7 square root 2, or 7 square root 2 squared. And so if you were to square each term, like doing it in your head, 7 squared is 49, square root of 2 squared is 2, 49 times 2 is 98 square centimeters, which is the same exact thing as if you were to say area equals 14 sine 45 and then squaring that. You'd get 98 both times. So that's the point I'm trying to make here. You'll get the same answer whether you use special right triangles or trigonometry, because after all, special right triangles work because of trigonometry. So for my final example, I'm going to do the area of this regular hexagon. And so you see you have 3 as your side length. So if you were to redraw just the right triangle, you'd have to cut the 3 in half. So you'd have to use 1.5. And so what we need to figure out is the apothem here. So I need to figure out x. I can put a little x there too if that helps. And next thing I need to do is determine what my central angle is. So a hexagon has 6 sides. So do 360 divided by 6 and you're going to get 60 degrees. That means this whole angle is 60. So that means this angle is half of that, which is going to be 30 degrees. And so you have 30 degrees here at the top, 90 degrees at the bottom, and 60 degrees here. And so what we have is a 30, 60, 90 triangle. Remember, a 30, 60, 90 triangle, the pattern is the short side, you can just call S or X, and then this would be your S square root 3 side. So that is just going to be 1.5 square root 3. And then your hypotenuse, just for the sake of it, is your 2s side, which is just 2 times 1.5, which is 3. So just because I brought it up in the previous example, let's say you didn't recognize that this is a 30, 60, 90 special right triangle. How would you solve it using trig? Well, I'm looking for x, right? And so just you pick one of the angles. You can pick the 30 degree angle or the 60 degree angle. I'll just pick the 30 degree angle. And x is going to be adjacent to that 30 degree angle, and 1.5 will be opposite of it. So what uses the opposite and adjacent sides? That's tangent. So what you'll do is you'll take tangent of 30 degrees, and you'll set that equal to your opposite, 1.5, over adjacent, which is just x. And so if you have x on the bottom, then this is where it makes more sense to throw this over 1, because if you were to cross multiply, you do 1.5 times 1, that's 1.5, divided by tangent of 30, and that's what x would equal. So long story short, if x is on the bottom of the fraction, you're going to say x equals 1.5 divided by tangent of 30. And so that's what x equals. And remember, x is our apothem. So you can say x is 1.5 divided by tangent of 30, or you can say that it is 1.5 square root 3. They're the same number. So doing your area, you're going to say area equals 1/2 times, pick one of these two terms. I'll just use 1.5 square root 3, and then you have to multiply that times your perimeter. Well, we had a side length of 3, and then it was a hexagon, so that means there's 6 of them. So 3 times 6, or you can just say 18. And then, like I said, you could do the alternative of 1/2 times 1.5 divided by tangent of 30 times 3 times 6 or times 18. Either one, type them into the calculator, you get the same answer. And that answer is 23.3826, which rounds to 23.383 square meters. And so that's going to wrap it up for my notes. Thank you for watching. Hope you learned something, and goodbye.